My name is Andrey, and today I'm going to talk about patterns for infrastructure as code. First, a few words about me. I always position myself as a developer, and that's what I do for a living, basically. But in the last few years, I have been involved so much in helping different organizations to actually automate different parts of software delivery that someone would actually call me a DevOps guy, even though I don't really like this title. It's a stupid title. I'm a developer, and I have a developer mindset. And I like automation, obviously. You can find my Twitter handle and follow me if you want. But let's jump into this talk. What's this talk is about? Obviously, it's about patterns and anti-patterns. And basically, it's a list of a collection of patterns that I'm going to go through. And probably you will see something new, or maybe you will see something that you already saw in your daily work. This talk is kind of work in progress, so it's never done, because the collection probably can grow, and some patterns may go away, some patterns may be more fine-grained, better defined. So feedback is very welcome. So if you guys have something in mind or you have some commands, tweet, send email, share, write a blog post. In any way, just try to share. So, infrastructure as code. I guess most of you guys are familiar with this term, or at least heard that term. And basically, it's a type of infrastructure that operations team can automatically manage and provision through code. Blah, blah, blah. That's the most legit definition coming from Wikipedia, of course. What I found during my playing and using different tools and in the area of infrastructure automation, I found that it has basically roughly these three areas where different tool types apply. The first one is the images, meaning that the base operating system images, the base container images, something that you use as a foundation for your infrastructure to make it more immutable, faster to reproduce. So you have a set of images that you base upon and you provision them later. The next set of tools is coming to the next area, and usually those are the tools that actually going to focus a bit more in the patterns and anti-patterns. Those are the tools that define the state of your infrastructure, which allow you to change that state and which allow you to manage that state. So things like Puppet, Chef, Ansible, and all of them fit there quite well. By the way, how many of you guys have used any of the provisioning tools like Chef, Puppet, Ansible? Nice, like almost half. And the rest of the automation tooling usually goes into the last area, where basically you implement your scripts, your tasks around anything like deployment, restarting machines, orchestrating any kind of delivery, and automating ad hoc tasks, backing up, restoring, whatever. Everything goes in the last area. But the other two areas are also important. And as you see, there's there's no strict boundaries between them, because some of the things you can manage with one set of tools, some of the things you can still manage with others. And it really depends on you, and sometimes you have to manage with both. Okay, let's go further. We have this main players in the infrastructure as code, main deliverables. One is image definitions, provisioning declarations, like Puppet scripts, Puppet manifests, stuff like that, and the rest coming into automation scripts, procedures. And if we're talking about the tools, I already mentioned that the image creation could be managed by tools like Packer, Docker, AWS. Any cloud provider has an image management tool. State declaration can go with Chef, Puppet, Ansible, Salt. There are many of them. And automation blocks, automation scripts can be implemented with anything, with any shell scripting protocol, with APIs, with any favorite language that you can use, Python, Ruby, Groovy, whatever. Let's go there. And the thing is, there are a huge amount of tools, tremendous amount of tools. This is a periodic table of DevOps tooling that comes from a company called Xebia Labs. And trust me, it's not complete. It's far from being complete. You have many tools that cover different areas, but all of them kind of, in my opinion, fall into that more or less category when we try to define our infrastructure. Because eventually, with the help of those tools and with the help of code, we make everything code. Everything is code. Everything that we can think of automating, everything that we can do about our infrastructure is becoming code. And the only good place for code is obviously this version control. It should be there, and the only way you put your code onto the infrastructure, onto your servers, onto your containers, should be coming there only through automation procedures. That's the only way. So the code deployments, or because now we're talking about managing servers, creating machines, creating environments and stuff like that. All of that can be done with a single click or with a single commit. We still have the same pipelines that we have for applications, for unit testing, building, and stuff like that. The same goes with any code, including infrastructure as code. So everything is becoming an automation process. Okay, let's see some patterns. And I've been working, as I mentioned, I've been working with many tools, and I've seen a lot of misuse of those tools, or maybe overusing, abusing the actual tool purpose to many extent, to a big extent. But still, let's start with the images. The first image that I think has a name is very old. Actually, the first pattern has a name. Actually, it's a very old pattern, and it's called golden image. And I think before we have a lot of virtualization available, before we had like cloud providers all over the place, this was the only way to do things. So you had create your base ISO image of your base operating system, and you did it once in a lifetime probably, and this was the only main starting point for you. So you didn't have a ability to change, to update that image, and everything on top of that was coming later with additional procedures, additional automation and stuff like that. Nowadays, it's much easier to manage base images, especially with the growth of containers. So this particular issue should not be a problem. That's why we have this nice pattern, which means reproducible images, basically, if you have an ability to recreate or update your base image, base image that you base your infrastructure on, that will save you maybe not a lot of time, but a lot of errors will go away. And there are tools for that, like Packer and Docker. Like Packer can help you manage the base operating images for your virtualization solutions or the cloud, and Docker can basically create containers, package containers with base images. And it's quite important to actually create a base image that all the rest of your infrastructure is kind of basing upon. Because especially with Docker, if you don't really manage how many images are involved in your Docker container cluster, you may end up running out of disk space. Like I've seen environments consisting of many Docker containers, and to start just a simple environment, just simple development environment, you had to download 10 gigabytes of Docker images, which of course is a mess because he was reusing wrong base images. Okay, let's go further. Next pattern, secret isolation. Well, the thing is, I already mentioned a few slides ago that everything is code, but the problem is that secrets, it's not code. It should be stored isolated, should be taken really good care of, because if you don't, well, you bring a lot of risk to your organization. Usually secrets should reside in a separate location, or at least they should be encrypted. And if you have some secrets built into your infrastructure as code, then obviously it should be extracted and injected at the very last stage of deployment or execution of your task. And as a continuation of that, secrets, of course, they should be first of all extracted, but then should be encrypted. And if you don't encrypt them, well, again, it's your big problem. Trust me. There are many options to encrypt things. Of course, you can encrypt your hard drives. Of course, you can even encrypt files in a version control, which is still is a good location for storing secrets if you encrypt them. Or you can use various vault services where the secrets are stored and are given to you on lease basis. In this way, you can probably have a more centralized control over that. Just an example of encrypting, you can use GPG. Plain old GPG is probably available on every operating system. Well, not Windows by default, but you can get it there. And you can encrypt files and put them in the version control. Of course, the process is a bit, especially if you use like, if you have to encrypt the file, decrypt the file every time you use it, that's not really practical, I would say. So there are actually options, especially for Git. There's a tool called Transcript, which allows you to write a hook. Well, it actually creates a hook on your local repository, which encrypts the file when you push it or you commit it, and decrypts the file when when you pull it, when you get it from the version control. That means that you, as a developer, will always work with plain text files, but the files themselves are stored in an encrypted form in the Git repository. That's pretty handy and relatively secure, unless someone has stolen your computer, of course. And then the master password, the one that is used to encrypt the things in your version control, this of course should be shared in a different way. They should be shared in different channels, so you shouldn't store the master password together with the encrypted values, because obviously that's a security breach. And as a result of that, another anti-pattern, postponing secret isolation. So people usually say, oh, okay, it's fine for now. We don't care about security. We need to move fast. Well, first of all, yeah, it's a bad decision right away. And if you don't think about security early enough, especially, hiding secrets is not that hard. It's not that hard. There are tools for that, as the one I mentioned, for example. So it's a bad excuse to say that security is blocking you, because it should not. There are tools for that. You can get over that. And besides, if you don't, especially when it comes to sharing secrets between dev environments and production environments, because it's probably fine to lose some secrets from the dev environment, but it's definitely not fine to lose some secrets from production environment. If you don't have a proper process for hiding secrets, for encrypting secrets, then it could make the communication between devs and ops, the ops who are supporting the production environment, much harder, because they know the secrets. They have to keep the code base secret, and in this way, developers cannot contribute to that. So it's quite important to extract things early enough and encrypt them and have the proper process around that, because this may actually allow you to get the DevOps mode work much better than without that. Okay. Another thing, next pattern, called infrastructure component DSL. That may seem a bit cryptic, but I would say that most of the people who try to start using provisioning tools, they usually abuse their usage. They don't really express their intent, they don't really apply domain-driven design to the infrastructure. So they just, they handle everything on a level of files and services and packages, but not on the level of the components of the system. So and therefore, infrastructure component DSL is something that most of the tools allow you to build second level, third level DSL, allowing you to express your original intent. So for example, if you have a system which runs HTTP application, which probably is most of the systems nowadays, you can actually express it with simple DSL say you have an HTTP application which is running behind the proxy, and you place it inside the component, and they have a database that running with some parameters of memory. This one can be read by anyone, so it's expressing the original intent of the configuration. And you can actually build this kind of DSLs of how your components, how your components create your system. You can build this DSL in anything. So it doesn't require any particular skills. You just need to use you can use any programming language, because just combining functions or classes will allow you to build these kind of things. But also tools like Puppet Chef and Ansible, they also provide you facilities to provide you second-level abstractions, third-level abstractions around different code bases, so different components. So they can allow you to group simple resources that, of course, they have as a building blocks into bigger building blocks, eventually having the proper level of abstraction defining how your system looks like. And talking about that, I've seen that many provisioning tools are often used just as a fancy file copying utility. So let's say you have to configure a package X, and you basically keep all the configuration files of that package X to yourself. So you make your code to be very explicit and copy every single file of that package over to the configured node. Well, that may seem as a proper use, but it's not. Because, for example, let's say Nginx. Everybody knows Nginx, right? It's a HTTP server. And let's say you want to configure Nginx. So you get into your provisioning code, you copy nginx conf, mimiconf, service conf, params conf, a lot of other accounts, and then you write, let's say, Puppet manifest or Ruby manifest or whatever, to copy that file, install the package, and copy all the files and install the package. So it may seem simple, right? But you actually hide the intent of your original configuration because you don't know. And anybody who will read this code will not know what is the intent of this configuration. They will not know what kind of components you wanted to configure by Nginx. So what you'll probably want to do. So yeah, files and package are not the right abstractions sometimes. So what would you probably want to do is you want to, let's say, configure the upstream server or virtual host or static directory, and that's what should be expressed in your provisioning code, because that's what you want to do. That's what the most important intent is. You don't want to copy files. You actually want to configure some components, and these components are well defined and well understood by anyone who knows what HTTP server is. The next pattern, incremental configuration. Again, talking about this fancy file copying, you don't need to copy everything, because in most of the cases, the packages that are living inside the package repositories, artifact repositories, they already have some sensible defaults. So you don't need to override that all the time. So you can actually rely on the default state and change only the things that you need. So sounds kind of easy, right? So if you want, for example, to configure SE Linux, you don't need to configure the whole thing. You don't need to copy all files of SE Linux, but you can just change the mode, the one single parameter that is expressing your intent. Again, much better. And I would like to emphasize that once again, that it's code, and the code is more often read than it's written. So you will have much more readers of your code than writers of your code. So it's quite important to express what is your intent. And that's true about any code, about application code, about infrastructure as code, about anything that is code. Because you're writing the code not for the machine to consume, you're writing the code for people to consume. Machine will be fine, it will understand that. But it's more important for a human being to understand that. Yeah, there's some examples of how to implement incremental configuration on different tools. Like, for example, in Puppet, there is a module called file line. You can just change one line of file instead of copying the whole thing. In Ansible, there's also line file and replace and stuff like that. On Chef, you can use the full power of Ruby to do that. Oh, sorry. Also, another thing, when you need to configure a package or a system that is actually quite complex one. Again, you shouldn't copy the whole thing, because this, again, hides your intent. But you can compose your configuration from different blocks. And again, the provisioning tools, they offer this, most of them actually offer an ability to compose complex configuration from several bits. They add additional abstraction on top of that, allowing you to build more complex stuff. Again, some examples for provisioning tools. In Puppet, you have concat module. In Ansible, you have assemble module. In Chef, you have partials. So again, instead of expressing your configuration as a single file copy, you actually express your configuration as a set of small abstractions that are composing the whole one. Another thing that is becoming very popular at the moment, especially with the rise of microservices when you have a lot of things to configure, is a configuration discovery. This is something that can make your provisioning code much simpler, because eventually, instead of hard coding or configuring some things for your packages, for your applications, you just let the applications discover those settings from some auto-discovery service. And there are many tools out there at the moment, Etsy, etcd, Eureka, Zookeeper, Console. So these are DNS. Some of them are DNS-based, some of them are just a key value stores that allowing to share the configuration of the cluster among different machines. And they discover it when they start. They don't need to be configured before they need to start. So it's kind of becoming runtime configuration instead of provisioning time configuration. Also, what I found quite useful in many situations is that if you have a boundary between your ops team and your devs team, If your devs actually basically are giving like disassembled application with all the bits and pieces with the configuration files and with some documentation on top of that to the other organization which does operations, usually it involves a lot of misunderstanding, because usually operations guys have to assemble it back and write some additional code on top of that, and it may not work very well. But the thing is, there are tremendous amount of different packaging formats, and if you as a developer think a bit ahead, and instead of giving your ops guys just a set of jars, if it's Java application, a set of Ruby files, if it's a Ruby application, just give them the package format that they expect, like RPM or DAP package or MSC if it's MSI if it's Windows, or even a Docker container. If you just give a Docker image to operations, that's going to be something that will help them to save the time on understanding what it does and to configure that and run it in production. So extra packaging code. And obviously there are many formats that are ready to be there. So as a simple thing, you can just make a zip distribution. As a more complex one, you can just create a container image and package it like that. But there are different challenges related to that. Okay, another one. Again, something that I've seen many times. When people are starting to use provisioning tools to actually configure something like all the users in their organization. And that's obviously, that's not configuration, that's data. And data should live in the database. And data has a different life cycle. It's more dynamic. And configuration, any provisioning code should become kind of a template that may apply may combine your data in some way or another. But because of the different life cycle, the data should not live in the code. So basically, when you add a new user to your organization, then you have to go and change the provisioning code, which doesn't make sense. Okay. And for that, to solve this kind of problem, for some of the configuration configuration data, you can actually combine configuration data with different data sources, and this works pretty well in some cases. Another one, again, we're talking about code, and there's an anti-pattern called ignoring styling guidelines. Every tool out there, most of them actually exist for many years. Some of them like more than 10 years old. They do have styling guidelines, but people just go and ignore them, and they write very unreadable, unstructured code, and everybody writes in a different way. Well, that's a bad thing, obviously, because if you are in a team, you have to follow at least the same guidelines. But since you're working in the industry, you have to follow more or less the same industry guidelines, because that will make life easier for many people. So go and find them if you don't know them. And as a consequence of the first one, people just not treating infrastructure as code. They think it's like, they call it script, they call it something else, but it is code. And as I mentioned, it should be in version control. It must be in version control, actually. You have to actually make code reviews around that. And yes, there are some tools for some of the provisioning tools. There are tools for making static code analysis. For example, in Puppet, there's Puppet Lint and Ansible. There's also something. In Chef, you can just use some tools from Ruby. It's also possible to test that code. So if you have a very good module to configure your configuration templates, you can actually run integration tests with that. Unit testing doesn't make a lot of sense for infrastructure as code, but integration testing does. You can actually do that, and especially with all the virtualization that we have now, you can spin off a server, try to provision it, and then verify the testing. And there are a couple of libraries like server spec and bots that can allow you to write your specification of what you expect from your machines. Well, another thing that probably you've heard of that, it's called DevOps. So your devs think, okay, it's code, then it's ours, then we do that. But the problem is that you have to involve the operations team as well, because there could be much loss on that if you don't do security properly, don't do backups properly, don't do testing properly, then yeah, could be a very big oops in production when you do final deployment. And DevOps kind of coming to this realization that if you may have late involvement of operations into the process, and that brings the problem that developers don't really care about what will happen with the application in production. Another thing, metrics as code, next pattern. Usually what I've seen is that all the metrics around your application, they actually are configured manually using the monitoring tool, or kind of semi-manually. But the thing is that the metrics for your application, the dashboard that you create, anything that you create to measure the performance and then KPI of your application is actually something that evolves together with application code. And it should kind of live together with that. And you should try to extract it and try to make it reproducible and try to see how the application structure actually influences the metrics as well. Yeah, there are many tools for that. I'm actually kind of running almost out of time. Another thing. Most of you will probably use some kind of tool to run your automations and configure and get the results of your automations. Many people actually use Jenkins for that. So they just, all the repetitive tasks, deployments, restarts, all of that is coming to a tool that may execute them and may provide some auditing on top of that. And again, many times I've seen that the configurations of those jobs, of those steps that are done in those jobs, they are actually done manually inside the UI. That's again a big mistake, because you can actually extract your control panel, Jenkins, Rundeck, whatever it is. You can extract configuration of that and put it into a version control as well. This will make it reproducible. This will make it auditable again. And you can also try to make the only way this configuration gets onto the control panel is through automation. So in case of Jenkins, there is of course Jenkins has an API. Plus, it has a job DSL, which allows you to define jobs as Groovy scripts, basically, and basically allow you also to define templates around them and reproduce the job set that you have very quickly. And there's also a Gradle plugin for that if you want. Also, we talk about Rundeck. There's another tool similar to Jenkins. This also has an API, has a command line, so no problem to automate recreation of your control panel in case of disaster. Okay. Anti-pattern, next anti-pattern. Imagine, well, there are quite many open source modules available for different provisioning software, for Puppet, for Chef, for Ansible. There's a huge amount of them. Not all of them are good, but there are good ones, of course. And what I've seen a lot, people just, making a private fork of a community module, they modify it to their needs, but they never share it back. So it's not really related to the infrastructure as code as such, but this is something that happens a lot. So instead of contributing back to the community, people just keep it for them. And one of the ways to kind of do it more in a better way is that you can actually create a wrapper around community module. So instead of changing it for yourself and never sharing back and never getting the updates back from the community, you can just create a wrapper, and then you have an ability to trace it better and see what are the changes and stuff like that. Okay, next anti-pattern. That's my favorite one. Imagine that you have some team working on the code base, and they have more or less automated most of their tasks. They have good defined structure in the version control. And apart from a couple of guys in the other end who still they want to help, but they don't know how. So imagine this is the structure that was created. Well, it doesn't matter what it does, but probably it seems that it's more or less logical, structural. And then suddenly, one day, the other two guys decided, well, yeah, we have these scripts. We need to commit them somewhere, and yeah, they just create the other directory called other stuff. So, I mean, first of all, to me, it's kind of obvious that this one doesn't follow the naming conventions that were set by the previous developers. But also, when you see things like that happening, like randomly committing stuff, and unfortunately in DevOps teams and in people who are trying to automate a lot of stuff, this happens because you just commit their stuff without understanding where does it fit or not. But this usually indicates the much bigger problem. This indicates that some of the team's members are actually not aligned with the team goal, or they're not aligned with the organization's goal at all. So this should be avoided. Yeah, probably skip this one. Yeah, this one is also important. Automation over documentation. How many of you guys have seen outdated documents that are not used by anyone? Well, yeah, most of you. Well, I guess all of you. How many of you guys have seen dead wikis, dead wiki pages that have been updated like 5 years ago and nobody cares about them? Exactly. Because documentation, it's born dead in most of the cases. Nobody updates that because it's not live. You can compile it, you can deploy it. It's just, some documents. Code, on the other hand, especially if it's actively deployed every, I don't know, week, day, whatever, it's live. I mean, you check it every time. And if you automate, and especially if you have an automation pipeline, the scripts that run that pipeline, they're checked by the system every time. So your automation scripts are say much more about your current system state than your documentation. So forget about documentation. Focus on the readability of your scripts. Focus on the clarity that you define in using the abstractions in your code, because this will survive much longer than your documentation. So automation over documentation. Another pattern is called environment template. That's quite easy. There are actually, again, quite many tools, because usually, your environments are not consisting of one server, and consisting of several. And if you have the template that you can create around that, you can actually gives you quite a lot of scalability, gives you isolation, and gives you flexibility, because it's just that. For local environments, you can use Vagrant. For remote environments in AWS, you can use AWS CloudFormation. Also, you can use Terraform, and things like Docker Compose also can help creating templates of the whole setup and making it quick to spin up things. And another consequence of infrastructure as code being code is that it's quite easy to create a big ball of mud. So you can create it with any code, doesn't matter. And unfortunately, yes, it happens all over the place. With application code, with infrastructure as code, it happens. So no doubt about that. Okay, I'm kind of done. This is a summary of patterns. So reproducible images, secret isolating, encrypted secrets, infrastructure component DSL, incremental configuration, configuration composition, configuration discovery, extra packaging code, configuration data source, metrics as code, control panel as code, community model wrapper, infrastructure query language, automation over documentation, and environment template. And the bad ones are golden image, postponing secret isolation, fancy file copying, data as code, ignoring style guidelines, not treating it as code, DevOps, private fork of community module, other stuff, and big ball of mud. That's it. Thank you.